Today we're going to tell you a little bit about jet engines. These are also known as continuous combustion engines. This is a basic jet engine. While there are many configurations, all jet engines contain the same basic components: an inlet, a compressor, a combustion chamber, a turbine, which provides power to the compressor via a spool or shaft that runs down the middle of the engine, and an exhaust nozzle.
Here we see an engine similar to the one in the previous slide. However, this engine has had a nose cone and exit nozzle added. Another difference is that this engine is a twin spool engine. The advantage of having a twin spool engine is they are more efficient because they allow you to better optimize the compression ratio in the turbine and compressors. This is done by allowing a low pressure compressor to be powered by a low pressure turbine and a high pressure compressor to be powered by a high pressure turbine. This has two shafts, one running inside the other, which are allowed to spin independently of each other and at different RPMs. Here again we see the same twin spool engine from the previous slide. However, this engine has an addition of an afterburner. An afterburner provides brief periods of increased thrust to allow like a fighter jet to dash in and out of a combat situation. This afterburning stage is added between the turbine and the nozzle. In the afterburner, more fuel is sprayed into the hot exhaust stream and ignited by the flame holders. While this is not as fuel efficient and cannot be maintained, it does provide a large increase in thrust.
If an aircraft design calls for lower speed and higher fuel efficiency, a basic jet engine's core can be used to power a propeller. In this type of engine, very little thrust is provided from the exhaust stream, though an exhaust nozzle is still used. A turboprop offers advantages of better reliability, better fuel economy, and a shorter takeoff distance over similarly powered piston engines. In cases where a turboprop cannot provide the necessary fuel economy, operating altitude, or speed, the propeller can be replaced by a bypass fan. These look similar to compressor blades. However, some of the air does not go through the engine. A significant portion, up to 80%, is directed around the core of the engine. This provides greater mass flow rate and therefore more thrust without burning additional fuel. There are two types of turbofan engines: high and low bypass ratio. Low bypass ratio engines can be used in conjunction with afterburners, such as in the F-35 Joint Strike Fighter.
What we see here is a ramjet. You will notice this engine does not have compressor or turbine blades. Even still, it still follows the same concepts we have discussed before. The difference is that instead of using mechanical work to drive the engine, the compressibility factors of air above Mach 1 are used. A ramjet can operate at speeds up to Mach 6, which is much faster than a turbojet or turbofan are capable of. However, the downside is that they cannot operate at slow speeds because air will not compress enough to ignite. Therefore, for a ramjet to function, they need to be accelerated above Mach 1 before they can be used to power the aircraft. This is often used with either a small rocket engine or an auxiliary turbojet engine. This concludes our presentation. Thank you for watching.